And to find the mole ratio, I'm just going to compare their coefficients. So bromine has a 3 in front of it, aluminum has a 2 in front of it, so the mole ratio must be 3 to 2. Let's look at the next one. What is the mole ratio of aluminum bromide to bromine? Well, here's my aluminum bromide, here's my bromine. I have 2 aluminum bromides, I have 3 bromines, so my mole ratio must be 2 to 3. Easy enough. Okay, let's look at this last slide here. So we're going to get into writing these stoichiometric calculations, and these are going to be big and they're going to be bulky, but I promise after tomorrow when we do examples of them, you'll do awesome. So all stoichiometric calculations must begin with a balanced chemical equation. So you are either going to be given a reaction, or I'll give you words and I'll want you to write out a balanced chemical reaction. Most often I'll probably give you the reaction, but there will probably be a couple times where I'll ask you to write one out. You could be asked to do one of the 3 following things in terms of a stoichiometry calculation. We could go from moles to moles, I could have you go from moles to mass, or I could have you go from mass to mass. And there are steps to help us go along with this. These steps, and I'm just going to talk about them today really quickly, so then that way tomorrow whenever you get to class, we can just immediately start working on some examples with these. So first step, you'll see your equation, or you'll write out your equation, then you want to balance that equation. It's super necessary for you to have this balanced correctly, because if you don't, your mole ratios will be wrong and then your calculations will end up being wrong. So we're going to balance the equation. That's the first step. Step number 2. You will probably be given mass most often, and if you're given mass, we want to always convert that into moles. Once we have our moles, we're going to go to step 3. Which means then we're going to set up mole ratios. So if you're already given moles and we're not given mass to begin with, step 2 doesn't even matter. So if I give you mass, you go to moles. But if you're given moles, then you don't have to worry about step 2, okay? So number 3, if I'm given mass, I'm going to convert it to moles, and then on number 3, I'm going to set up mole ratios. Once I've set up a mole ratio, on number 4, I'm going to use these mole ratios to calculate the certain number of moles that I want. And then lastly, we're going to finally convert moles into mass, if that's what it's asking for. But if I gave you moles and you just want moles, then you're done. You wouldn't have to convert it to mass. So this is super important that you either write this down to bring tomorrow to class, or print these notes off so that way you have an example. So that way these are just kind of our basic steps to work through these stoichiometric calculations. So this may not make a whole lot of sense right now, but it will make a total amount of sense tomorrow whenever we do examples of these. So this is where I'm going to stop right here. I, again, want you to write these down. You may have a small 3-question quiz on these notes tomorrow. So, and that one will be for a grade tomorrow, okay? The one today doesn't count. So make sure you have at least these steps written down. If you would like to, which I would prefer you to bring in a copy of these notes, I will see you tomorrow. And everybody have a great night. Bye.